Hello and welcome to our Outcome 8, so our 8th set of notes for college algebra. So we're getting closer to the end of this unit. We got Outcome 8 and then we got 3 more units outcomes after this. In Outcome 8 we're going to introduce this idea of adding, subtracting, multiplying, dividing pairs of functions. So just like we can take numbers and we can add, subtract, multiply, divide them, we can do the same thing with entire functions. Thankfully, it works pretty similar. Do the same kind of adding, subtraction, multiplying, dividing we've seen before in algebra class. But that's something we want to talk about and just talk about the notation and kind of show some examples. So you can have the sum of two functions. You can add them up. So you have a plus. So you'll see it like this, where they put f plus g. It means they want to take the two functions and add them together. You have the difference. So you subtract two functions. That means you're going to take the two functions and subtract them. The product. Here you'll see a lot of FG where they don't put anything between them. We know that with letters, when you put two letters next to each other, like F and G, it means multiplication. So a lot of times you'll see it like that. Or you might see a dot in the middle, and that means that we're going to multiply F times G. And here we showed a dot, but again, if you put no dot there, if you just put F of X next to G of X, that would be multiplication. And then quotient or division. So here we put F over G, and that's how we divide in algebra. So there, we're literally going to take the f function and divide it by the g function. So let's start off by taking and doing this with a couple functions. They're going to give us these two functions here. First function is 2x minus 5. The other one is x plus 3. So that's my g function, and this is my f function. And we're going to go through and we're going to add, subtract, multiply, and divide those functions. So first off, to add the functions, again, that's taking the first function, so f of x, which is this guy, and adding the second function, which is g of x, so this guy. So I'm literally taking 2x minus 5 and adding x plus 3. Now, when you add these, you really just end up combining like terms because it's got both have x's, both have numbers. So to do this, I'm really just going to combine like terms. 2x plus x is 3x. Negative 5 plus 5 is minus 2. And you can't go any further than like this because here we're just taking two formulas or functions and we're combining them to make one new function. We don't have any numbers to plug in. We don't know what the value is going to be after we get it out. We're just combining functions. We're taking two things and putting them together. This does happen in real life. This is actually something pretty useful because a lot of times you'll have a function that does something practical. Maybe it's a function that gives you dosage of one medicine, and maybe you need to combine it with another function, another formula for another dosage, and see how much total they're getting of a certain types of medicine. And so then by combining them into one function, you would get one function that gives you the total dosage for both medicines, something like that. Okay, next function we want to subtract. So now we're doing f of g of x minus g of x. You have to be careful with subtraction because the order matters. Remember, subtraction, you have to really be careful about what order you're doing. So we want to make sure we put the f of x function first. So we get 2x minus 5 first, minus the g function, the second function, which is the x plus 3. And one of the big mistakes people make with subtraction is they subtract just the first part and they forget to subtract the rest of the function. So when you do this, you always want to put a minus, you want to put a parenthesis around here on the second function, because you want to remember that this minus is applying to everything inside that second function. So this minus is counting on both parts. So I get 2x minus 5 minus x, subtracting x, and minus 3. So we're subtracting 3. We're subtracting both parts. Now that I got this minus distributed to both parts, now I can go ahead and simplify this by combining the like terms. I got 2x minus x is just x. Negative 5 minus 3 gives me minus 8. And that would be my answer for that one. I forgot to box my last answer. There you go. So x minus 8 would be my answer. That's the combined version when you subtract. Again, this is only f minus g. If you did it backwards, g minus f, you would actually get a different answer. Next one, I want to multiply. So I'm doing f of x times g of x. I'm multiplying these functions. So I'm going to take the 2x minus 5, the first function. I'm going to multiply it times the x plus 3. Now this one, again, I want those parentheses because I need to show the multiplication that when I multiply these, multiply all these parts with all those parts. This one's not so bad because you can just do it with a FOIL because there's two parts here, two parts there. So if you remember your FOIL from the previous algebra class or maybe high school, FOIL just tells you to multiply the first part. So do 2x times x. 2x times x, I get 2x squared. The outside parts, so you take the 2x and the 3, so 2x times 3, you get 6x. the inside parts, you get the negative 5 times x, so you get minus 5x. And then the last parts, the negative 5 times 3. So you multiply those, you get negative 15. So that's what you get for that one. All right, combine the middle parts because these are matching terms. So just to simplify, combine those, I get x, because 6 minus 5 is 1. So we get 2x squared plus x minus 15. And that would be the answer. That's the combined when you multiply them together. Okay, last thing we want to do, the division. So I'm taking f of x, the function on top, divided by g of x, the function on bottom. Again, order matters. Which one you put on top and bottom will definitely matter. Here, f of x is that 2x minus 5. G of x is x plus 3. And we'll put them in a fraction. And in this case, that's it. You're done. Because that is a fraction. This one does not simplify at all. You can't make this nicer. So that is it. It's just going to be a fraction. And now it's the function you get if you divided the two functions. Now, finding these, the addition, the subtraction, the multiplication, the division, that's actually really half the battle. Because there's a second part to this. The second part of this is all about determining the domain of your functions. So we want to be able to figure out the domain. Well, the nice thing is there's actually a rule about the domains. When we combine functions, their domain is equal to the intersection of the domains of the functions used to make them. So the domain is equal to the intersection of the functions used to create them. What this means is, when you think about domain, remember domain for functions is the numbers that you're allowed to plug in, the numbers that work for x. We said the only time we have to worry about domain is, remember that with domain, we need to watch out for fractions because we don't want to divide by 0, so watch out for fractions. And for roots, because we don't have to have square root of a negative. Those are the things we want to watch out for. And if we have either of those, if we have a fraction or root, then we might have to remove stuff from the domain. If you make if x being a certain number makes the bottom of the fraction 0, then you can be in trouble. Or if you have a square root and put x a certain number in there and it makes square root a negative, then we don't want to use that. Otherwise, we're usually pretty safe because everything else is going to be fine. In fact, for these two, both of these two functions, both of these, the domain for these two functions, because they have no fractions and they have no roots, is going to be negative infinity to infinity. And since the domain is the intersection, or what they share, that's what intersection means. It's what values they share. What's in both domains? Well, since they both have the exact same domain, negative to infinity, the domain of these intersections, of these combinations, is going to be everything, negative infinity to infinity. There's nothing they have to worry about. You'll notice that if you look at the answer here, 3x minus 2, there's no fractions, there's no roots, so its domain is negative infinity to infinity. That's true. If you look at the subtraction, again, we get x minus 8, there's no fractions, no roots, so its domain is negative infinity to infinity. Same thing with multiplication. I multiply these two, I get this guy down here. There's no fractions, no roots. This one, its domain is negative infinity to infinity. Now, the one exception is the fractions, because when we divide the two functions, we actually make it into a fraction. And by making a fraction, now we have to worry about the bottom of the fraction. So if you do this with quotients, where you make a fraction, you always have to say, don't let the bottom part, don't let that be 0. Whatever makes that 0, that's going to be something not in our domain. Well, in this case, negative 3 is going to make that 0, right? Negative 3 plus 3 is 0. So x can't be negative 3. That's the one number we're going to avoid. We don't want negative 3, because negative 3 would make this guy 0, and then we'd be in trouble. So the domain for this last one, the domain is not going to be negative infinity to infinity, because we have to take out the negative 3. Now, everything else works besides negative 3. So we can start from negative infinity, and we go right up till we get close to negative 3, and then we stop. Remember that parentheses means we get close to negative 3, and then we stop. We don't quite reach it. We'll jump right over top of it, because we don't want to include the negative 3. On the other side, we'll start on the other side of negative 3 and go off to infinity. And so we've really just skipped the negative 3. We didn't want negative 3, so we want everything else. Everything below negative 3, everything above negative 3. That's the domain for a function like this. So when you make a fraction, it's a little more complicated than the rest. You can't just combine what you got to start with. You have to say, okay, the bottom can't be 0, and then you can make your domain. Let's try one more set of these. We'll try combining them, and we'll try to talk about their domain. Maybe we'll talk about domain as we go this time. So this time, let's look at our two functions. Our two functions here, we have 5 over x and negative x 3x plus 2. So note with the first one, the domain of this first function, his domain, is not going to be everything because this one actually is a fraction. So the domain on the bottom here, we're not going to be allowed to use 0 because if you put 0 on the bottom, you're dividing by 0. So the domain for this one is negative infinity to 0, but we're going to skip over 0, so 0 to infinity. So we're skipping 0. Don't use 0 for this one. The domain for the second one, though, this one doesn't have a fraction or a root, so its domain is everything. Its domain is negative infinity to infinity. Now, we said before, you can actually find the domain of the combinations of these functions using these two domains to start with. And we'll say that when you add, the domain of the addition, the function you get when you add, is just going to be the domain, the intersection of these two domains. What do they share? Well, they share everything except 0, because this domain, this function, doesn't work with 0. So I know before I even figure out what it is, the domain of this function, the domain for this function, is going to be everything except 0, because it's the only thing not shared. So its domain is going to be negative infinity to 0, union 0 to infinity. Everything except 0. That's the domain for this function. Now let's actually find the combination so we can just double check and see if we did this right. So to combine these, I'm doing g plus f. So I'm taking the g function, which is negative 3x plus 2, and I'm adding the f function, which is 5 over x. So I'm adding those together. Now this one, there's no simplifying you can do. Oh, I forgot the x, sorry. Negative 3x plus 2. There's an x in both parts, but this one's on the bottom, that one's on the top, so they do not combine. So there's no combining we can do on here. We can't simplify this at all. So that's the furthest we can get. And you notice that with this function, there is a fraction with an x on the bottom. So 0 would not work, because if I put 0 into this function, we get 0 on the bottom. We're not allowed to do that. So 0 is the only problem. So even without knowing what the function was, we were able to figure out the domain. So that's handy sometimes. Sometimes you just need to know about the domain, even if you don't know what the function looks like. If you know the original function, you know that the combination is going to have that domain, but it's the intersection of those two. That's what they share. Excuse me. Let's try the next one. This one's subtraction. Now, because it's same two functions, f and g, and now we're subtracting, it's going to have the same domain, because for addition, subtraction, multiplication, the domain is always going to be the same. So this one is still going to be domain negative infinity to 0, union 0 to infinity, because this time, again, we're looking and saying these two functions, the only thing they don't share is 0. So we took the 0 out, and we said everything below 0, everything above 0 is the domain. And then let's try it. Let's subtract them. So if I do f, that's 5 over x. So I get 5 over x, that's f. And I subtract g, so I subtract g. Don't forget your parentheses, right, when you're subtracting. You get 3x plus 2. Then that's subtracted. Now, my math lab probably won't like having a minus and a parentheses. They probably say take this and simplify it a little bit. You distribute this negative through, because that's how we get rid of that parentheses. You can think of it like multiplying by a negative 1 if you want, because you need to multiply something through to get rid of the parentheses. I got 5 over x. Negative 1 times negative 3 is positive 3x, and negative 1 times 2 is minus 2. And then that's simplified because we got rid of the parentheses. Notice you cannot combine like terms again, because there's nothing that are like terms here. So this would be our answer. And again, the only thing this is going to have problems with is 0, because if you put 0 on the bottom, you're in trouble. So that's the only number we avoid. Okay, this next one's a little different, because here you notice I'm using the same function twice. There's no rule that you have to use two different functions. I can add the same function to itself. I can do g plus g or f plus f. Here I'm just doing g times g. Now notice with function g, we had no issues, right? The domain with function g is everything. So since I'm using g both times, the domain for this one is going to be everything. I'm not using f, so I don't have to worry about that 0, because I didn't use the f function at all. I'm just multiplying g's together. So in this case, I'm going to have domain be everything. Okay, so g is that negative 3x plus 2. So I'm going to take negative 3x plus 2, and I'm going to multiply it times itself. Because that's what g times g means, multiplying the same g times itself. I'm doing g of x, which is negative 3x plus 2, times g of x, multiplying it times itself. That's what we're doing. Again, this is going to be a FOIL problem, because I have 2 parts here, 2 parts there, so I can FOIL. I do first, negative 3x times negative 3x is positive 9x squared. Could do by outer, negative 3x times 2 gives me negative 6x. Could do the inside, 2 times negative 3 gives me another negative 6x. And then I can do my last, 2 times 2 gives me positive 4. With this, I can simplify a little bit because I can combine those middle terms. So negative 6 plus negative 6 is negative 12x, so plus 4, and still a 9x squared in the front. And that would be as simplified as you can get it. Again, once you simplify it, you can look at this and you can see that that does have the right domain, right? There's no fractions, there's no roots, so this domain should be everything. So you can do this either way. I've been doing it where I figure out the domain ahead of time. You don't have to actually do that with these. You can actually go ahead and just figure out what the function is and then check its domain. Look for the fractions, look for the roots. If there's none, then its domain is always everything. So let's try one more. This one's the fraction one. So remember, with the fraction one, you have to be careful because when I look at the domain of the combined fraction, I can't just combine these two. I have to worry about what goes on bottom. So this might be a case where I might not try and figure out it ahead of time because it might be easier to actually just figure out what happens when you divide first. Let's try that. Let's do g over f and see what we get. Well, g, notice, is the negative 3x plus 2. So on top, we're going to have negative 3x plus 2. On the bottom, we have f. So on the bottom, we have 5 over x. Okay, well, this is awful because we end up with a fraction inside a fraction, right? We say the 5x over x is a fraction inside a fraction. We call this a compound fraction. That sounds awful because it kind of sounds like compound fraction. And honestly, it's probably about as much fun. They're not nice things to have. So most people, when they see a fraction inside a fraction like this, a compound fraction, the first thing is to make it into just a regular fraction. We don't want a compound fraction. And there's a couple ways to do this. If you have where the bottom fraction is like this, a fraction, the easiest thing to do is just to take that fraction, flip it over, and multiply. Because remember that we divide fractions by flipping and multiplying. So that's probably the easiest way to deal with this. In this case, is to flip and multiply. Then we don't have to deal with having fractions inside fractions. So this is going to turn into negative 3x plus 2 times x over 5. And since I'm multiplying this whole thing, I'm going to use parentheses, so I distribute. So that's the trick, is if you have a fraction inside your fraction, you can flip that bottom one and multiply by it. It only works if it's on the bottom. So if you have a compound fraction with some on top, we have to deal with that differently. So here we do this one. Again, we're going to distribute it to both parts. So this would become x over 5 times 3x. Well, that becomes negative 3x times x is negative 3x squared. But then we get the 5 on the bottom. And x over 5 over 2, well, we get plus 2x over 5. Now that one is not a compound fraction anymore because it's just two parts. These are regular fractions, and so there's no compound fraction, and that's good. The problem is, if you look at this and you say, what's the domain? You might think that the domain is everything, right? Negative infinity to infinity. Well, that's actually not right. Because although it looks like this doesn't have any fractions, and I say it doesn't have fractions because it doesn't have any fractions with x's on the bottom. That's what I'm really worried about. Like 5 on the bottom, that's not going to cause any problems, right? Because 5 is at 0. So you can have numbers on the bottom. It's really when we have x's on the bottom that we worry about. So this one looks like the domain might be everything. But if you look back before we flipped and multiplied, you look back to here, you notice that we were dividing by 5 over x, which means that we still actually have x on the bottom back at this point. And right here, this is enough for us to say, okay, because of this point right here, where x is on the bottom of the fraction, we can't let x be 0. If a letter x is ever on the bottom of a fraction, it's going to give you something you have to take out of your domain. I like to call those restrictions. If I ever use the word restriction, I'm talking about the stuff that we don't want in our domain. So in this case, we don't want 0 still, because 5 over x was on the bottom. So if you think about it, the function that was on bottom is 5 over x, and the only thing that was going to cause problems with that is if we divide by 0 there, and so 0 is going to be the issue there. So in this case, we'd say that the domain, again, is negative infinity to 0, but not including 0. So we'll use union, and we'll jump over 0. We'll just do everything below 0 and everything above 0, and that'd be the domain for this one again. So you can't always look at the very end. Up here we did, and it was fine because the domain was everything. But sometimes you might have something like this where before you get to the end, it'll show up here. And this is an issue right here. So, okay, we don't want that on the bottom to be 0, so we can't let x be 0. So then that's the number we have to avoid. Okay, we got a couple more examples for this section. I think we got a couple more pages. Really good. Yeah, three more pages actually. Okay. So with functions, one of the primary things we do with functions is we evaluate them, right? We plug numbers in and we solve. Now, when you do this with combined functions you got by adding or subtracting, multiplying or dividing, there's actually two different methods to do it. So I'm going to show both methods for each of these. The first method is to combine them first and then plug in the number. So when you see here, this 2 going in there, this means that x is going to be 2, but we're going to wait until after we've added the two functions together, and then we're going to plug the 2 in. So that's what this method is. The first method is to combine first. So I'll take my functions f and my functions g, and we'll combine them together. So I'm going to add them together. I'm going to take 5 minus 2x plus this guy, which is 3x squared minus 4. I'm going to combine them. I could simplify that a little bit, right? Because I can combine the 5 and the negative 4, and you get 1, right? 5 minus 4 is 1. We'll put the 3x squared in the front, because I always like to put the x squared, the highest powers in the front, and we'll put that minus 2x in the middle. And the 5 minus 4 gives me a positive 1, so that's a plus 1. Okay, so that's the first thing. That is finding combined functions. So this is f plus g of x, right? That's the combined function. Then we take that function and we plug in the 2. So we do f plus g of 2. This is just saying plug in 2 for x. So I do that, and so I plug 2 in. I get 3 times 2 squared minus 2 times 2, and then add 1. And I'll get the result. So this is finding what you get when you plug 2 in. So here I get 2 squared is 4, because you always square before you multiply, right? So I do 2 squared is 4 times 3 is 12. 2 times 2 is 4 plus 1. So 12 minus 4 is 8 plus 1 gives me 9. And that would be your result. So that's the answer to this. The answer is 9. Because we are actually plugging a number in now, we get a number out. That's the difference. Before we weren't plugging a number in, we were just finding the combination and calling it good. Now the second way to do this is to actually plug in first. So that before I find the combined function, what you get when you combine them, I'm just going to plug the 2 in to both functions. I'm going to do f of 2. I'm going to do g of 2. I'm going to do that first before I add them, and I'll add after. So let's do f of 2 first. I'm going to plug 2 in here. So I got 5 minus 2 times 2. So I'm plugging 2 in first, right? So I'm plugging 2 in for x. So 2 times 2 is 4, so I got 5 minus 4, and 5 minus 4 is 1. So that's the first part. I get 1 for the first part. But now I got to do g. So this function g, I plug 2 into that. So I get 3 times 2 squared minus 4. Plugging 2 in for that x. 2 squared is 4 times 3 is 12. 12 minus 4 is 8. So now after I've done both functions, then I add them. I do the combining adding part last. 1 plus 8 gives me 9. And you'll see that I got the same answer either way. So that's why it doesn't matter which way you do it. You can combine the functions first and then plug a value in, or you can plug the value in and then just add them at the end, because you don't have to add them first. Now, why might you do one way versus the other? Well, you might do this way for a problem like this one, because it might be easier, right? Instead of trying to add the functions or subtract them or multiply them, it might be easier just to get the values, 1 plus 8, and then add and do that. And that's usually true if you're only using this function combination once. If you're only going to plug one number in. Now, in real life, a lot of times you'll take two functions, you'll combine them, and get a new function that you're going to use over and over and over again. You're going to plug lots of numbers in. And so in that case, it's better to do this, where you take these two functions or formulas. A lot of formulas are functions. You take two formulas, you combine them, and get a combined formula, and then you sit there and plug your different numbers you want in. Because you have to do this whole process every single time versus doing this process once, and then just plug a number in over and over again, especially if you take this function and put it in a calculator, where you can just feed a different value. You know, if you write a program or use like Excel, you can do that, where you write a little equation and then just switch out the letter for x, the number for x. In that case, it might be a lot faster to do this way. And so that's why people want to do it both ways. So you can combine them first, get the combined function, and then plug your number in. Or you can plug your number in first, get the two different values, and then combine them at the end. And it works both ways. We'll try the next one. We'll do the same thing. I'll switch sides, so I'll do green on this side this time. So first I'm going to combine. So g times f, so I'm going to combine with do g times f. So I'm going to find g f of x first. So I'm going to combine by multiplying. Remember, when they're next to each other, that means multiplication. So I'm going to take g function, which is 3x squared minus 4, and then multiply it by the f function, which is that 5 minus 2x. 5 minus 2x. So I'm going to do that first. I'm going to multiply first. When you multiply functions, again, you're foiling. So I'm going to do my first 3x squared times 5, so I get 15x squared. Do my outside, 3x squared times negative 2, so I get negative 6x cubed. My inside, negative 4 times 5, so I get negative 20. And then in my last, negative 4 times negative 2x gives me positive 8x. Multiply those parts for my last part. So that's my function. And I take that function and I plug in my value. So this one doesn't simplify or anything, so that's done actually. So now I'm going to take that function and I'm going to plug in the value they gave me. They gave me negative 2 this time, so I'm going to plug in negative 2. So for all these x's, I'm going to replace them with negative 2's. So I get 15 times negative 2 squared minus 6 times negative 2 cubed minus 20 plus 8 times negative 2. Just plug in negative 2 in all the spots. Negative 2 squared is 4, so I get 4 times 15. So negative 2 cubed is negative 8, so I get 6 times 8 minus 20. And 8 times negative 2 gives me negative 16. 15 times 4, that's going to be 30, 60, so 60. 6 times 8 is 48, and a negative negative makes a positive. Minus 20 minus 16. So now if I combine those, I get 60 plus 48 is 108, minus 20 is 88, minus 16 is 78, minus 6 is 72. So that's 72. Let's see if I double check myself. That would be 32, 12, 32. Yep, so I get 72. That's what I get. That's the combine first method. If I wanted to do it separately, I want to find g of 2, negative 2, and f of negative 2, and then multiply them, that would be the other method. So g of negative 2, again, g function, I have that 3x squared minus 4. I'm going to plug negative 2 into that, so I get 3 times negative 2 squared minus 4. And then I'm going to multiply that answer times the other one, f, which is the 5 minus 2x. So I get 5 minus 2 times negative 2, because I'm plugging negative 2 in for x. And I'm going to find those two values and then multiply them. So here I get negative 2 squared is 4, so I get 3 times 4 minus 4. And then 3 times 4 is 12, so I get 12 minus 4, which gives me 8. That's the first part. Second part here, I have 2 times 2 gives me 4. Negative negative makes a positive. So I got 5 plus 4. And then 5 plus 4 gives me 9. Right, so 8 times 9, and my answer is 72. So it works both ways. So that's the idea. So you can combine them and get a combined function and then plug your value in and solve. Or you can plug it into each one and then do your process of multiplying to combine them at the end. And again, you probably see that on the problem like this one, it's probably easier to do it this way. You just multiply them, you get the answer, because you're only doing it once, right? We're not plugging that in over and over again. If you're going to plug multiple values in, that's why people would do this combining method first. And it's good practice to combine, because you're going to need to know how to find the combined functions. You'll see that in the homework. So you can always do that just for practice, combine them first and then plug your number in. That's a good way to practice for the test, but that's the idea. So you should be ready to add, subtract, multiply, and divide these functions. That's something you'll see on the test. Okay, next thing I want to talk about is graphs. Now you can use graphs to evaluate functions. So we can actually use graphs to evaluate function combinations. So instead of having the equation, I don't know what f and g are, I don't know what their equations are, I can just take the two function graphs and use those to figure out the value. So something like f plus g of negative 2, I can do f of negative 2 and g of negative 2, because I can evaluate those off a graph and then combine those by adding. So remember, when you evaluate off a graph, you're figuring out that x is the number we plugged in, so x is negative 2. And so I go to negative 2 and I find the f function. Well, the negative 2, the f function is right here. So negative 2, it looks like it's about 4.5. So we'll say this one is 4.5. G function at negative 2 looks like it's right here. G function is going to be 1. So for g, we get 1. So negative 2, we get 4.5 for the f function and 1 for the g function. So we can evaluate those two different values using x is negative 2 and then find the y, the heights, and then add those together and we get 5.5. So if you have a function's graph, you can still evaluate even a combination where you add it together. Try the next one. I want to do g and f multiplied, right? When you have g next to f, it's multiplied. So I'm going to do g of 1. I'm going to do the first one, plug g into the first one to the first one. And then I'm going to do f of 1. Could put 1 into both, right? I'm doing 1 into both of them. And then multiply. We're going to multiply afterwards. So I do g of 1, so x is a 1, right? X is a 1. Go over to 1, and I get g function is going to be right here, right? So it's negative 2. So this one gives me negative 2. To the f of 1, so f of 1, it's right here, and that's 3. right? So x is 1, so I got 3 and negative 2, so I got 3 and negative 2, and we multiply those. Negative 2 times 3 gives me negative 6. So we do when we multiply them. Do one more. Let's do g minus f. So I'm going to do g of 3, do g of the 3, minus f of the 3. So f of 3. So g of 3. So I go over here to 3. That's my x. G of 3 is going to be all the way down here. It's going to be negative 4. So g of 3 is negative 4. And f of 3 is right here. That value is 2. F of 3 is 2. So negative 4 minus 2, well, if you subtract 2 more, you end up at negative 6 for that one. Negative 6 is the answer. Now, when you're doing these, you'll notice that one, I barely hit the graph here, so I could do that. But if I had asked you about like g of 4, or sorry, f of 4, you notice I wouldn't be able to do anything because f doesn't go all the way over to 4. So when you're working with functions with your adding, subtracting, or multiplying, dividing, you do have to worry about whether or not you can use the graph like this because the piece might not keep going and it might stop. And you might get to a point where you only have one value and not both. Or you go to 5 and it doesn't work for either graph. So you can only do this for certain numbers. So you do have to worry about the domain of these functions. Now the domain of these functions, again, is the domain you get by combining the functions as indicated. So like when I want to do, addition, subtraction, multiplication, division, then I'm looking at these two functions and I'm thinking, okay, if I'm going to add these, can I add them? Well, yeah, right here I can add f and g, I can do it in the middle. When I get too far to the right or I get too far to the left, then I can't do anymore because the values don't exist. Like even right here, g stops here, so if I go over a little bit more, it's not going to work. So first off, let's talk about the domain. The domain for f, it starts at negative 5 and it goes over to 3. So the domain for f is going to be from negative 5 to 3. And the domain for g starts at negative 3 and goes all the way over to negative 5. So g is from negative 3, sorry, not to negative 5, to 4. Whoops, I read the y value. I'm supposed to be reading the domain. The domain is always x values. So from negative 3 to 4, 3 to 4. And I don't know why I put parentheses here. These should be brackets, because you always use brackets when you actually hit the endpoints for domain, right? Domain is always brackets. The only time we were always using the parentheses when we saw that, like, increasing, decreasing constant, and that's not what we're talking about. We're talking about domain. Domain, you always use the brackets of the count. And so here, we're going to treat these as like they actually touch the ends here, and so we'll say brackets. Okay, so when I go to do my addition, multiplication, subtraction, in order to do this, I need to have both values exist. So I'm not going to be able to do anything at negative 5, because negative 5 works for this one, but it doesn't work for this one, because it stops at negative 3. So numbers like negative 5, negative 4, that doesn't reach that far. So we have to start at negative 3 on all of these, because that's the furthest left we can go. Now we can start here at negative 3. We can't go any further left. And then on the right side, we stop at 3, because on this right side, we have to stop here at 3, because we can't do anything over at 4, because there's no f value at 4. So we go until we hit 3, because that's as far as we can get. And for addition, subtraction, multiplication, all those are always going to be the same, because you just have to have both exist. You have to have both graphs be real at those points, and that's all you're looking for. So we can go all the way down to negative 3, we go all the way up to 3 for all of these. So those ones are always going to be the same, addition, subtraction, multiplication. The only one that's going to be different is going to be division, and that's because, again, we have to worry about the bottom. Remember that when you have f over g, that means f of x over g of x. The one thing you have to worry about is that g of x, the bottom, can't be 0, right? We don't want that to divide by 0. So what would make the bottom 0? Well, the bottom would be 0 if this g function gives us 0, and it gives us 0 right here. So this is where g of x equals 0, and that happens at negative 1. So x can't be negative 1, because if you plug in a negative 1 for x, you get a 0 for g, which means you're dividing by 0. We're not allowed to divide by 0. So we'll say don't include negative 1 in the set. Now everything else from negative 3 to 3 works, right? Because you could do negative 3, you can do 3. Now we couldn't do like negative 4 or negative 5, because again, we wouldn't be able to divide because g does not exist at negative 4, negative 5. So we're still limited between negative 3 and 3, but we also want to take out negative 1. So this one, the domain for this one, is going to be from negative 3 to negative 1. Don't include the negative 1 because we don't want that negative 1. Union negative 1 to 3. Because again, we can go until we hit 3. We just don't want to include that negative 1. And that's the big difference there. So when you're working with graphs like this, where they don't go on forever, they stop, you have to watch the ends. Because at the ends, they don't have a value. At the ends here, where only one exists and not both, or if you go past where neither exists, then you can't do it. So you got to rewatch the main for those. Okay, last thing. Now this last part for this is something that won't be on the exam, but I'm leaving it in the homework because it's a good practice for when you get to calculus. Now I know some of you are going, I'm not ever taking calculus, and that's fine. That's why I'm not going to put this on the exam, so you don't have to worry about this for the exam. But it was on the homework. This is called the difference quotient. So the difference quotient is kind of an idea of thinking about the slope of a line when you have a curve. Now the problem is we can't talk about the slope of a line for a curve typically because the slope changes over the curve, right? As you go along the curve, the slope changes. But in calculus, we get this idea of thinking about as things get really small or as we get close to a certain value, what happens. And so calculus, they have to start to think about, well, what's the slope of a line at a certain place? And so they use this idea. They use this idea of difference quotient. You'll see difference quotient a lot if you take calculus. I'll show you how we're going to use it. It's not too hard. It'll be in the homework. But again, like I said, I'm not going to throw it on the test. So you don't have to worry about this for the exam. Okay, so if you're looking at the slope of a curved line, we can draw a line called a secant line. A secant line is a line that crosses at 2 points like this. This would be called a secant line. Finding the slope from the points where the secant line intersects, so finding the slope of that line, is a good part of finding calculus. And what we do in calculus, we try and make this line get smaller and smaller, the points get closer and closer together, and that kind of helps us find the slope of the curved line. That's what we work on. So we finding the slope here. So if I want to find the slope of these 2 points right here, you notice the first point is going to be x, and the next point we're going to say we're going to take some amount h. We're going to say, okay, we're going to step over h amount and get the next point is going to be x plus h, because it's h more than x. So that would be your x values. And then your y values, well, are going to be the function's value at x. So what does it give you at x? And the function's value at x plus h. What is f of x plus h? And those are the y values. So this difference quotient, literally what it is it's them taking the y's, which is the f of x and the f of x plus h, and subtracting those, y2 minus y1, and the x's down here and subtracting those. But when you do x plus h minus x, the x's cancel, and that's why you're left with just h. So this is actually the slope formula, just applied to these kind of generic versions of your points, because we don't know exactly what x is or x plus h is. Okay, so we're going to find the difference quotient. It's another thing you can call is the average rate of change. So it's basically talking about the change of the slope over time. Let's look at this difference quotient for a function f of x. So this function f of x is 4x minus 3. Now, first thing to talk about is, in order to do all this, we need to know what f of x plus h is, because you can't do anything unless you know f of x plus h is. Well, since we know f of x is this, f of x plus h is just taking this function and replacing x with x plus h. So I'm going to take that, and instead of 4 times x, I'm going to have 4 times x plus h minus 3. So that is the combined function. So f of x plus h gives us that 4 times x plus h minus 3. Okay, so now that we got both of those, we got f of x, we got f of x plus h, and we have h, we can put this difference quotient together. So if f of x plus h is this thing, so we get 4 times x plus h minus 3. F of x is this thing, so I'm going to subtract that. Be careful here, since I'm subtracting this, I definitely want to make sure I put parentheses so both parts get subtracted. So I get 4x minus 3, all of that's being subtracted. And then I divide that by h. So divide by h, give me my difference quotient. Now I want to simplify this a little bit. So the trick to simplify this, I'm going to first off go ahead and just distribute. So I'll get rid of these parentheses. So let's get rid of some parentheses because that'll get this a little bit simpler to work with. 4 times x is 4x, 4 times h is 4h, minus 3, and then I do a minus with the 4x, so I get minus 4x, and a minus with the 3, so I get positive 3, still over h. Now I notice that some things cancel, right? We have a minus 4x and a plus 4x, and a minus 3 and a plus 3. So after you cancel all that, you're left with just the 4h and just the h. Well, now I have multiplication 4h over h. You can see that I have an h on top being multiplied, h on the bottom being divided, those h's cancel because they're opposites, multiplication, division. So my final answer is just 4. So in calculus, this is what you'll end up doing eventually. If you did take calculus, you take a function like this and you do a difference quotient and find out the answer is 4. And that'd be the number you'd use for your calculus class. And then you'll find out quicker ways to get that in calculus because eventually they'll kind of show you shortcuts. But that's the idea. Now, for our class, that's all I'm going to want you to be able to do is you'll be able to take your function, plug in x plus h instead of x. So you get this part, and then put those together, f of x plus h, this guy, and f of x being subtracted over h, and then just simplify it, right? Combine like terms, distribute, simplify it down, and you get to something simplified. Okay, let's try the next one. This one, a little more complicated because it's a fraction, so let's do this fraction one. So I want to do the same thing. First, I need to figure out what I'm going to do f of x plus h is. So I'm going to replace the x here with x plus h. In this case, I get 1 over 2 times x plus h. So x plus h goes in there for that x. I should mention this one. I really want to show you this one again because it's going to be kind of tricky on the homework. And again, I'm not going to put this on the exam, so you don't have to worry about these for the exam. But I did want to show you this so that when you get to the homework, you kind of know what's going on. Okay, we're going to do the same thing where we take f of x plus h minus f of x. Take this one minus this one. So I get 1 over 2 times x plus h minus 1 over 2x. And then I take that whole thing and divide it by h. And you see that we're back to that situation where we have compound fractions, right? I got fractions inside fractions. Now I like to do that flip and multiply kind of thing if I can. This one's a little different because I've got 2 different fractions. I've got an h. So something I'm going to probably do on this one actually is I'm probably going to get some like terms. Oh, sorry, some common denominators because I want to be able to subtract these two. Right now they have different denominators, so I can't subtract them. So I'm going to do a trick. I'm going to get common denominators here. Now, if I look at the denominators, I can see this one has a 2, and this one has an x plus h. This one has a 2, and this one has an x. So what I do is I think about what they're missing. So this one has x plus h, but it doesn't have an x by itself. So this one's missing an x. I'm going to take the top and the bottom here, and I'm going to multiply them by x so they can get both of these parts in here, both the 2 and the x. This one has the 2, has the x, but it doesn't have the x plus h because x is different than x plus h, right? Those are 2 different numbers. So this one I'm going to multiply the top and the bottom by x plus h. So it's getting common denominators. We're getting the denominators to match. So we end up with this looking like this, where on the top we have x. Over here we have x plus h, because we multiply by x plus h, and 1 times anything just stays the same. So that's x plus h. And on the bottom of both of these, we have that 2 and an x and an x plus h. I put this in a different order just because you can move the x in the middle because multiplication, the order doesn't matter. So that's how I'm going to rewrite it like that. This side over here, I'm going to have also 2 times x plus h. Okay, and that's still over h. But now that I have matching denominators on the top, I can actually do the subtraction. So I'm going to keep going. I'm going to take these two and I'm going to subtract them. I'm going to take x on the top here minus x plus h. But be careful when you subtract a fraction like this, make sure you subtract both parts. So I'm going to subtract x plus h, and parentheses, going to subtract both of those. Okay. On the bottom, these two combine, so I get 2x times x plus h, still over h. So we're getting a little simplified. We're getting there. Next thing, I'm going to go ahead and distribute the top. So I get negative x, so I get x minus h over 2x x plus h over h. You can see the x's cancel. So those cancel. So I get negative h over 2x x plus h thing over h. And the last trick here is to use that flip and multiply trick again. Now that we got just a fraction on the top, fraction on the bottom, so now we can see we have a big fraction like this. We can actually take and we can multiply by the reciprocal. So we end up with, I'm sorry, I should say this is the fraction on top. This is the h on the bottom. So what we do is we treat this h as a 1 over h, or as a h over 1, and then we can flip and multiply. So we end up with the top, negative h over 2x x plus h, times this guy flipping over 1 over h. And why would we do that? Because then this cancels, right? multiplying with a h on the bottom and h on the top. And those h's can cancel. So your final answer is a negative 1 on the top, and the bottom you get 2x times x plus h. I don't know, I'm supposed to box that. So that one's a little tricky one. So I don't know if I wanted to show you kind of what to do on that one. Again, I'm not going to make you do difference quotients on the exams. So get through them on the homework and then just don't worry about them. You know, if you're going to see calculus eventually, you'll see them come up then. And so that's why I want to keep them in here so I can kind of give you a little preview. You get the calculus, you'll see them happen again. But for our class, once we're done with them in this section, just from the homework, you're not going to see them again. Now, combining functions by adding, subtracting, multiplying, dividing, that you will see later on, so that's definitely important. You want to pay attention to that, make sure you're ready for that. That stuff will show up on the exam, but this stuff, you know, the difference quotient, it's more just a little preview for future calc students. And that's it for outcome 8. So like I said, outcome 8, we did the difference quotient, we did the, looking at the graphs and combining the functions, and then we evaluated these functions where we plug numbers in. You definitely want to be able to plug numbers into the combined functions. And we did all the, adding, subtracting, multiplying, dividing those functions. Next time, outcome 9, I believe we're going to get into combining functions in a different way. So it's an important way that we'll show you next time. But, that's all we're going to cover this outcome 8 is just these 4 different ways to combine functions. So I'll see you on the next set.